everyone, and welcome back to our functions lessons where we will determine the equation for the hyperbola. Now remember, the hyperbola is of the form y equals a divided by x plus q. So when you have the asymptote and any other point, now this is quite easy because we've been doing it in linear equations, and with the parabolas we're doing the little bit of substitution of the other point into the values of x and y, right? So if you are given the asymptote, well, there's the asymptote and they give us the equation for the asymptote, which is y equals 2. So it means that it goes through the y-axis at 2, right? So basically what you have to remember is that a parabola is of the form y equals a over x plus q, and then we put in the asymptote. So this will be y equals a over x, and then what is the plus q? It's a 2, a plus 2, so it will be plus 2. Okay, so far so good. Then we take the other point, and I'll circle that for you, and then we take the x, we put it in x's place, we take the y, we put it in y's place, and we solve for a. So here's quite easy. So 5 equals a over what is x? It's a 1 plus 2, and that means the 2 goes to that side. It becomes a minus 2 when we move the constant terms first. You remember that from our equations, right? So that means 5 minus 2, which will equal to 3 equals, and then we know a over 1 is just a. If that was a different value, remember we will just multiply with the LCM right through, or you can just take this, and because we divide with it on this side, we will just multiply with it on the other. So a over 1 is a, so a equals 3. And then we are done. I can simply write the function as fx equals, and then we have a, which is 3, divided by x, and what is q? Plus 2. And you can see you are correct because a is positive, it's in the positive quadrants. My asymptote is at plus 2, so it moved the quadrants up a little bit, and we're gonna have an x-intercept. Now how will we get that x-intercept if we are asked? Well, we just make y 0 and solve for x. Brilliant. So let's go try another example. Now here is another example for you to try. It's quite easy because we've been doing it for linear equations and parabolas, and now we're just doing the same for hyperbola. What we want is, we hope that they give us the asymptote, because then we just go and we write y equals, and we know that this is a parabola, right? So it's of the form a divided by x plus q. First of all, write the initial equation. There we go. Put in the value of q. Okay, it's minus 3. So that means y equals a over x minus 3. Great, okay. And remember, I'm just going to write this again because many times they ask you what is the equation of the asymptote. Because it goes through minus 3 and it's a horizontal line, we know that it is y equals minus 3, right? Okay, so y equals a over x minus 3, then substitute in the other points x and y values to solve for a. So we take this point here, the other point, and we put the 1 into x's place and the minus 6 into y's place. So let's do that. So y is equal to minus 6 equals a over 1 minus 3. Then the constant term goes to that side, it becomes a plus 3, and minus 6 plus 3 is a minus 3 equals a over 1. And again, because this is a 1, I'll just show you what I'll do. We are just going to, because we divide with the 1 here, I'm just going to get rid of it here by multiplying with it on the other side. So this will just be a minus 3 equals a, and there we go. So fx equals minus 3 over x, and what is my asymptote? My asymptote is also minus 3, and there we go. And we can check to see if we are kind of correct, because it's a negative a, they are both in the negative quadrants, and the asymptote moved down 3 places, it's at minus 3, and there we go. And we will also have an x-intercept there. How can we calculate it? By making y 0 and solving for x, because the x-intercept, my y's are always 0. Okay, so write the equation in full, there it is, and we are done. Excellent. So that is all there is to finding the equation of hyperbola, and now you know the linear equation, the parabola, and the hyperbola, and in the next lesson we will go and look at the exponential function. Bye. This is your host Richard T, and thank you for joining us. Please visit our website mathsa.co.za for free guided exam tutorials.